Okay, in this video, we're going to learn on how to draw tree diagram by applying the Bayes theorem. So first thing, when you have question for tree diagram, you need to understand the question by identifying what are the events given in the situation. Okay, then you need to know what are the possible outcomes under each event. And lastly, you need to know how to identify the probability given is for which events or for which outcome. Okay, now let's look at this example. A counselor classifies his student as excellent, fair, and poor students based on the overall performance in their final examinations. Okay, so here we have one point here: excellent, fair, and poor students. Excellent and fair students constitute 10% and 30% of the students, respectively. The probability that a student will score A for mathematics for excellent, fair, and poor students are 0.6, 0.3, and 0.1 respectively. Okay, now what are the two events? Okay, so first here you have students who are excellent, fair, and poor. So this one is the outcomes from the student. So here, excellent, fair, and poor student, we can classify it as student status. Okay, it can be anything as long as suitable for excellent, fair, and poor. Okay, then here on last sentence, it said that the probability that a student will score A for mathematics. Will score A for mathematics. Okay. So second event will be either the student will score A for mathematics and the complement will be will not score A for mathematics. Okay, so that is the first thing that you need to know from the situation given. Okay, now let's look at on how to draw the basic tree for this problem. Okay, in order to ease us to label the tree diagram letters, so we just use notation, okay, or symbol to represent each outcome. So let's say I put let E is for excellent student, P for poor, and F for fair student. Okay, so this is for the first event, means that for the status of students. Okay, then another event will be score A for mathematics. So the complement will be not score A for mathematics. Or another example, if you have defective item, the complement will be non-defective item. So here let's say I put A score A, and then event that is not or elements that is not belong to A, we put it as A prime. Okay, so A prime will be not score A. Okay, now how to draw the tree diagram. Okay, look at the first event. We have three outcomes. So meaning to say that you will have three branches. So this is the first step. Draw the branches. Okay, then you put label. So here is for excellent. Here is fair, and then last one is for poor. Okay, once you label, assign the probabilities. Okay, what is probability for excellent student? So excellent student is 0.1. So here 0.1. Fair student is 0.3. So what is probability for poor student? Okay, recall total probability must be equal to 1. Okay, so total event, one event here must be equal to 1. So how to get probability of poor students? You use complement rule. So 0.1 plus 0.3 is 0.4. So balance will be another 0.6. Okay, 1 minus 0.4. Okay, next branch will be for either the student score A or not score A. So how to draw the branch? So each student, so this excellent student, either he will score A or he will not score A. So similarly, for fair student, either he will score A or he will not score A. And last one for P also similarly, either score A or will not score A. Okay, then put label. So just now here is score A. Score A is A, not score A is A prime. Okay, then assign probabilities. Okay, look at here. The probability that a student will score A for mathematics for excellent, score A, so referring to here, for excellent, given excellent, A given excellent are 0.6. Okay, so here is 0.6. So if excellent score A 0.6, so what is probability excellent student who did not score A? So again, total probability for one event must be equal to 1. So if score A 0.6, who did not score A will be 0.4. Okay, next, score A for fair 0.3. So fair who score A is 0.3. So who did not score A will be 0.7. Okay, lastly, poor student who score A, whose score A is 0.1. So here will be 0.1. So did not score A will be 0.9. Okay, done. That's how we draw tree diagram. So the following questions will be based on this tree diagram. Okay, now look at question B, C, and D. So in order to ease you to answer question B, C, and D, so I advise you to calculate all values directly, means that all probabilities values directly from the tree diagram. Okay, so later on this answer for B, C, and D, you just refer the tree diagram. Okay, now look back on our tree diagram here. Okay, so here you can calculate probability A intersect E. Okay, so how to calculate this probability? So simply you multiply 0.1 multiply by 0.6. So here 0.1 multiply 0.6. So this one we will get 0.06. Okay, similarly for the rest of the outcomes, you can calculate the probability. So here will be probability of A prime intersect E. So here equal to 0.1 multiplied by 0.4. which is 0.04. Okay, continue the same step until last outcome. I just copy here to save time. So here will be a prime intersect f. So 0.3 multiplied by 0.7 is 0.21. Here is A intersect P. So 0.6 multiplied by 0.1. So 0.06. And last one is probability of A prime intersect P. So 0.6 multiplied by 0.9. So this one 0.54. Okay, recall. So each event, the total probability must be equal to 1. So note here that each branch here total must be equal to 1. Each branch here also must be equal to 1, the total probability. This one also must be equal to 1, and last one also must be equal to 1. So as a whole, so total probability here also must be equal to 1. Okay, so if you calculate 0.06 plus 0.04 plus 0.09 plus 0.21 plus 0.06 and last one 0.54. So total probability must be equal to 1. So when you calculate probability, it cannot be more than 1 and cannot be negative. Okay, let's go back to question B, C, and D. So to answer that question, we will base on these three diagrams. All answers are based on these three diagrams. Okay, now let's look at question B. Find the probability that a student chosen at random is classified as fair student and will score A for mathematics. Okay, will score A for mathematics. So from this three diagram, okay, find branch for fair students who score A. Okay, so from this three diagram, it will be this part. Okay, fair student who score A. So how to write your answer here? Find probabilities of P, fair students F, and will score A for mathematics. And submit the intersection. Fair student who score A. So F intersect A also equivalent to A intersect F. So what is the probability? 0.09. So since you already show your calculation here, so no need to write 0.3 times 0.3 back. Okay. If you want to write your final answer directly also, no problem. If you want to write this way also, no problem. Okay. So since we already show all the calculations in three diagrams, so if you write your final answer like this also, should be no problem. Okay, C, find the probability that a student chosen at random will score A for mathematics. Okay, so we want to find probability students who score A. So this one is given by probability of A intersect E or, so if or plus, okay, probability of A intersect F or probability of A intersect P. So what is the probability? So A intersect E is 0.06 plus A intersect F is 0.09 plus A intersect P is 0.06. So here the answer will be 0.21. Okay. Okay, now question D. A student did not score for A for his mathematics subject. What is probability that he is an excellent student? He is an excellent student. So this is question for conditional probability. Okay. So what is the condition? The condition is did not score for mathematics. Did not score A for mathematics. So how to write your answer? So we want to find probability. Probability of what? Probability he is an excellent student. So P E given. So given did not score A. So did not score A is A prime. So this is conditional probability. So probability of E given A prime equal to probability of E intersect A prime divided by the condition. So now the condition is A prime. Okay, what is probability of E intersect A prime? So if you look at your tree diagram, E intersect A prime is E intersect A prime intersect E, the same thing. So the probability is 0.04 divided by probability of A prime. So from question C, we know that probability of A is 0.21. So A prime is complement for A. So simply here you apply complement rule. So 1 minus 0.21. Then you will get probability for A prime. So here 0.04 divided by 0.79. So the answer here will be 0.05, 0.0506. So if you look at here, the probability is very low for excellent student will not score A. Okay, so normally we will say that if excellent student, the probability or the chance for him or her to score A is high. Okay, so for example, maybe you will get 0.9 or 0.8. Okay, means that the probability is high for excellent student to score A. Okay, so that's how we draw tree diagram by applying the Bayes theorem. So after this, we will look at another example, example 27. Okay, let's look at this example. A doctor is studying the relationship between blood pressure and heartbeat abnormalities in her patients. She tests a random sample of her patients and notes their blood pressure, high, low, or normal. Okay, so this one will be the first event. And their heartbeats either regular or irregular. So note here that this one will be the second event. She finds that 14% have high blood pressure, 22% have low blood pressure. Of those with high blood pressure, 15% have irregular heartbeats, and those with low blood pressure, 5% have irregular heartbeats. She finds that only 2% of those with normal blood pressure have irregular heartbeats. Okay, first step, always list the notation that we want to use based on the events. Okay. Okay, here let I use B blood pressure high, so let's say H for high blood pressure. L for low blood pressure, and N is for normal blood pressure. Okay, second event is about their heartbeats. So I use R for regular and R prime for irregular. Or if you want to use I also, no problem, okay, as long as you define. Okay, for first event we have 3 outcomes. So let's draw the branches. Okay, then you put label. So here is high blood pressure. Here low, and last one is for normal. Okay, then assign the probabilities. So high, what is probability for high blood pressure? 14%, so 0.14. Low is 22%, 0.22. So normal will be 1 minus 0.14 minus 0.22, which is 0.64. Okay, so total must be equal to 1. Okay, now outcomes or branches for second event. So for each blood pressure, either there has regular heartbeat or irregular heartbeat. Okay, now assign the label. Regular, so here regular, regular. Here is R prime. Okay, now assign the probabilities. Okay, look at this sentence. Of those with high blood pressure, so despite 15% have irregular heartbeats. Irregular is R prime. So here is 0.15. So those with regular heartbeat will be 0.85. Okay, so 1 minus 0.15, you will get 0.85. Of those with low blood pressure, so this part, 5% have irregular heartbeats. Irregular again here, 0.05, so regular heartbeat will be 0.95. Okay, last one, she finds that only 2% of those with normal blood pressure, so this part, have irregular heartbeats. So our prime here 0.02. Here will be 0.98. Okay, now let's calculate probability for each outcome. So here will be probability of H intersect R. So this one equal to 0.14 multiply 0.85. So here will be 0.119. Okay, next. So here will be probability of H intersect R prime 0.14 multiplied by 0.15. So 0.021. Then here probability of low blood pressure intersect regular heartbeats. So 0.22 multiplied by 0.95. 0.22 multiply 0.95 is 0.209. So next here, low blood pressure with irregular heartbeats are prime 0.22 multiply 0.95 is 0.011. Next, normal blood pressure intersect regular, so 0.64 multiply 0.98. So 0.64 multiplied by 0.98 is 0.6272. Last one, probability of normal normal blood pressure intersect R prime, 0.64 multiplied by 0.02. So this one equal to 0.0128. So again, total probability for each event must be equal to 1. So if you calculate here, 0.119 plus 0.021 plus 0.209 plus 0.011 plus 0.6272 and last one is 0.0128. So total must be equal to 1. Okay, now look at question B. What is the probability that a patient selected at random has irregular heartbeats? So we want to find probability patients with irregular heartbeat. So here you can write P irregular just now is R prime equal to, okay, now look at outcomes with R prime. So here we have probability of H intersect R prime, okay, or so plus probability of low intersect R prime, or so plus probability of normal intersect R prime. So H intersect R prime is 0.021 plus L intersect R prime 0.011 plus last one N intersect R prime 0.0128. So this one the probability is 0.0448. Okay, last question, question C. If a patient selected at random has regular heartbeats, so if here another keyword for conditional probability. So has regular heartbeats, what is probability that he has high blood pressure? Okay, now we want to find probability of, so how to write this? What is probability? What is probability? So P, he has high blood pressure, so H, if a patient, if means that the condition. So given has regular heartbeat, so given R. So here equal to probability of H intersect R, so divided by the condition which is probability of R. Okay, probability of H intersect R is, so H intersect R, so this one 0.119 divided by probability of R. So here in question B, we have probability of R prime. So how to find probability of R? So either you use complement rule or you add this part. So we want R only, so you add 0.119 plus 0.209 plus 0.6272, okay, for regular heartbeats. Okay, instead of you add that one by one, okay, you can use complement rule as I said before. So the simplest one we use complement rule. 1 minus probability of R prime. So here the answer is 0.1246. Okay. Okay, that is example for tree diagram. For the rest of examples, so these two examples, you do it on your own. Later on, I will give you the answer.